Hello everyone, good morning. This is Mr. Dakshunaamurthy, Assistant Professor, Artificial Intelligence and Machine Learning Department. I am handling subject 21 CS 003 Mobile Application Development. Unit 1 Wireless Communication and Cellular Networks. Topic is Multiple Access Technique. Multiple access techniques. Here multiplexing versus multiple access. Multiplexing is a way of sending multiple signal or streams of information over a communications link at same time in the form of a single complex signal. Multiple access is a technique used to allow multiple users to access the channel at the same time without any interference. In other words, multiple access is a application of multiplexing. Multiple access techniques: frequency division multiple access FDMA, time division multiple access TDMA, spectrum multiple access, and then space division multiple access SDMA. Spectrum multiple access again classified into frequency halved multiple access or co-division multiple access and hybrid spectrum technique. Here, the frequency division multiple access FDMA, the low frequency which is denoted for the user 1, here it takes more time, and in the next range, here it is the mid level of frequency for user 2, the time is getting reduced, that means the frequency is high, and so on. This is the frequency band. Here we are creating the guard bands to avoid the interference. Each and every user, we are allocating the separate frequency channels as shown in the diagram. FDMA assigns individual channels to individual users. Each user is allocated a unique frequency band or channel. The channels are assigned on a demand by the users. The same frequency is not allotted for two different users. The bandwidth of FDMA channel is relatively narrow, 30 kilohertz. FDMA are usually implemented in narrowband systems. The amount of inter-symbol interference is low, and thus no equalization is required in FDMA narrowband systems. FDMA is continuous transmission systems, whereas it required less overhead compared to TDMA. FDMA uses duplexers since both transmitter and receiver operates at same time. This results in increase in cost of FDMA. FDMA requires tight RF filtering to minimize the adjacent channel interference. Nonlinear effects in FDMA. FDMA, many channels share the same antenna at the base station. In order to get the maximum power efficiency, the power amplifiers and power combiners are operated at near saturation region. At near saturation region, the power amplifier, power combiners are nonlinear. These nonlinearities cause signal spreading in the spectrum domain, the frequency domain, and generate intermodulation frequencies. This spreading will interfere with the adjacent channels, causing adjacent channel interference. in this above graph, we can able to see the saturation region. It lies at the side at this portion. Here, the cushion point we are making. Once we are giving the input waveform, the upper portion of the input waveform is getting clipped. We are getting due to the nonlinearity properties. Capacity of FDMA, the number of channels that can be simultaneously supported in FDMA systems is given by n is equal to bt minus 2b, that means the 2b divided by bc. Here bt is the total spectrum allocation, b guard is the guard band allocation at the edges of allocated spectrum, bc is the channel bandwidth. Summary: multiplexing versus multiple access we discussed. Multiple access is an application of multiplexing, type of multiple access techniques. Time division multiple access TDMA. Here all the entire signal is a uniform frequency, whereas we are allocating at the different time slot. That means in the three-dimensional graph we can able to see each channel is allocated in the time slot, and these signals consist of three fields. One is preamble, and another one is information message, last one is trail bits. Here user 1 is allocated at time 1 slot, and user 2 is allocated time 2 slot, and user 3 is allocated different timing time 3 slot. This message is passed at the different timings, time slots, whereas the frequency of the signal is common for entire signal. Time division multiple access TDMA. TDMA divides the entire radio spectrum into time slots, and in each slot only one user is allowed to either transmit or receive. Each user occupies a cyclically repeating time slot. TDMA system transmits data in buffer and burst method. This makes the transmission a discontinuous one. Hence, this makes the TDMA systems more suitable for digital systems. Systems use TDMA/TD or TDMA/FDD methods for duplexing and multiple accessing. In TDMA/TDD, the single frame will be used as forward link for half of the duration and as a reverse link on another half period. In TDMA/FDD, two different frames will be used for forward and reverse link, but the carrier frequency will be different. Understanding TDMA frame structure, user 1 having a different unit of information, user 2, user 3 and so on. This information, first user 1's one block of information is sent to the carrier channel, and user 2 is sharing the another first block of the information, and simultaneously user 3 is completed. Then we are giving chance to user 1 and so on. It is similar like a round robin case. Each and every user can able to send one block of information at the given particular time. TDMA frame structure we discussed till now. Time division multiple access TDMA.